Hi guys, so I'm coming to you today from my basement little setup of a whiteboard. So it's not like super clear and it's kind of fuzzy, and I'm sorry, I'm working on my own personal computer, so I don't have the better webcam, but we're just going to kind of make do. So today we're going to do half of 1.3. So this is all factoring. So we're going to do two different types of factoring, and then we're going to leave the other two for a different video and a different day's assignment. So we are going to deal with first factoring with trinomials. So the first one we're going to show you is x squared minus 9x plus 20. Okay, so here we go, plus 20. So some expressions that we work with are going to be able to be factored, and some simply won't. That's our job to kind of see whether or not it can be. So the very first thing that I have to do when I'm factoring trinomials, okay, so I keep saying trinomial. Tri means 3, right? Like mono means 1, bi means 2, tri means 3. So if you have 3 terms in this expression, so that's 1, 2, 3. Then it's a trinomial, and you're going to factor it using this method. I find all factors of 20, okay? So I take 20 and I say, I want to know what are all the different numbers that multiply together to get me 20. So we have to think about always you have 1 in itself. So that's going to be 1 and 20. Then 20 is an even number, so I kind of like to start at 1 and work my way up. A lot of people say like, oh, I had the worst time trying to make this list. So I wouldn't try to just make the list like grabbing random factors. I would start at 1 and start working your way up. Go 1, is there factors of 2, is there factors of 3, 4, 5, and so on. So we've done 1. Now, is 20 divisible by 2? Yeah, it is. That would be 2 and 10, right? 2 times 10 gives me 20. Now, is 20 divisible by 3? Nope. Not evenly, at least, right? You can't divide 20 by 3 evenly. So now I'm on to 4. Can I divide 20 by 4 evenly? Yes, that would be 4 and 5. Okay, so I'm on 4, I'm on to 5. I already have that factor. Now I'm on to 6. Can 20 be divided by 6? Nope. What about 7? Same thing, not evenly. 8 and 9, neither of those work. So now I'm back up to 10. So I've already got 10. If I go over 10, I am not gonna get any more factors, right? Because 10 can only be going twice, and then my next one would be 20. So these are my 3 factors. So these are the numbers I get to choose from. The one I need to choose is whatever adds up to be negative 9. Okay, so when we factor, the way we factor is we find 2 numbers that multiply together to be the last number and add together to be the middle number, and signs do matter. So when I start thinking about like, okay, well, what numbers could even get me to 20 or get me to negative 9? So one thing that's really important is to remember that we can use negatives. So it does still have to multiply to be positive 20 and then add to be negative 9. So 2 negative numbers, when they multiply together, makes a positive. So either of these numbers could be also negative. Okay? So the way I'm going to get to 9, 1 and 20. Any way I combine those, positive or negative, I'm either getting 19, negative 21, positive 21. None of those are 9. So 2 and 10. If I add 2 to 10, I'm getting positive 12. If I subtract 10, I'm at 8. So those aren't working either. Okay, so this one didn't work, this one didn't work. Now with 4 and 5. 4 plus 5 is 9, but what if I make these both negative? Okay, negative 4 times negative 5 is positive 20. Negative 4 plus negative 5 is negative 9. So these are the 2 that I'm going to use. When we find the two factors that we're able to use, we set up these two binomials. In the front of each binomial goes a single x, okay? Every single time. You will always set up two of them with a singular x. The first one takes one of those factors with the sign, so -4. The second one takes that second factor with the sign, so that would be -5. And that's it. Okay, that's all we have to do for these. Okay, so let's do another example. And keep in mind, sometimes it's just not able to happen. So let's do x squared minus 3x minus 12. Good, okay. So again, first thing we do is we start a running tally of factors of 12. So two things that multiply together to be 12. Always we start at 1 in itself. Okay, now let's work our way up from 1. 2, 12 is divisible by 2. That is 2 and 6. On to 3. 12 is divisible by 3. That's 3 and 4. It's divisible by 4. We've already used that factor. It's not divisible by 5. It is by 6. We've already used that number. It's not by 7, 8, 9, 10, or 11. Okay, so these are our three factors. So once we've gotten these, now, first off, they have to multiply to be a -12. So very first thought is only one of these can be negative. Okay? One has to be negative and only one can be negative. So whenever I'm trying to add these up, let's make sure that I always have a negative factor in one of those, right? Because if it's a -12, that is not made by using a positive and positive, or a negative and negative. It's made using a negative and a positive. So adding up to -3. Will 1 and 12 ever get me down to a -3? Never, ever, ever, no matter what kind of combination I use. What about 2 and 6? Okay, let's try a -2, +6, or a -6, +2. -2, +6, +4, -6, +2, that's -4. So those aren't working. So I've scratched that out, I've scratched that out. Same thing with 3 and 4. -3, +4, +1. +3, -4 is only -1. So none of these are adding up. Okay, they're multiplying to be -12. None of them add to be -3. So what we say is, this is not factorable. And that's it. We can't factor it. There's nothing we can do to be able to factor this. So we leave it as is. Okay. Let's see. Okay, I'm at about 8 minutes, so I'm going to do one other kind. So that was factoring trinomials. This specific type of factoring is called difference of squares. Okay, so for difference of squares, we have a very specific kind of formula, I guess you can call it, that we're going to use. So the reason that these are differences of squares is it's literally a variable that's squared being subtracted from a constant that's squared. Okay, variable would be something like x. A constant is any number that's not attached to a variable. So 5, 7, 20, 500, any of that. So the formula that we use when we're factoring differences of squares, okay, is going to use an a and a b for both of them. So what you have to do is identify that a and identify that b. It's actually really easy to remember. It's one of them has to be positive and one of them has to be negative. Now the cool thing about multiplication is it's communicative. So you could flip either of these. So you could put the negative over here, the subtraction over here, and the addition over here. and you're going to get the same answer, okay? So it doesn't matter if you flip-flop those. So thinking about an example, let's factor x squared minus 49. So the first thing you should kind of be seeing is, ooh, we have a square, we have subtraction, but this is just a number, it's not a squared number. So that's our job. We have to turn that into a number that's squared. So what is the square root of 49? The square root of 49 would be 7, okay? So I'm going to rewrite this as x squared minus 7 squared. These two things are equal to each other, okay? Writing it as this way is equivalent to writing it as how I did up here. The reason I did that is because I want to pick out what my a and b is. So looking at this formula, here my a is squared, here my b is squared. But for the formula, I pulled just the a and just the b, not that value squared, right? So I need to know what my a and b values are individually to be able to plug these in. So I drop the squared off, basically, and that my a would equal x and my b would equal 7. So now let's write this out. Following the formula, I take my a and I put that in the beginning of each of these. I take my b and I put that in the end of each of these binomials. In one of them, it has to be a positive, and in one, it has to be a negative. And that's it. Okay? That's using difference of squares. Let's do one more example. I'll let you see that in case you need to pause it to write some of that down. So let's use a different example. Let's say m, right, because I can use any variable that I want, minus 121. Okay, so again, the way that I decide to use difference of squares is I have a variable that's squared, subtraction comes immediately after, and then I have just a constant. So this is basically a binomial that has two different terms. If there was a third, I can't use difference of squares. I can only use it when I only have two terms, both of which can be turned into a perfect square. So I'm identifying that I'm able to use difference of squares, so I'm going to, but I need to find the square root of 121. You can either do that in your head, put it in your calculator, either way, you're finding that the square root of 121 is 11. So now we go to the rewrite stage. And I can turn this into the equivalent statement that m squared minus 11 squared is the exact same thing. So now I go through and I pull out my a, I pull out my b, my a is m, my b equals 11. So we go through and we set up our two binomials. My a is in the front of both of these, so that's m and m. My b is in the back half, 11 and 11. I do one addition and one subtraction. And that's my factored answer. Okay, so that is it for this video. Like I said, just watch this video for the first assignment, and then we're going to do the part 2 of 1.3 on a separate assignment. So let me know if you have any questions, and that's all for this time.